This summer, I looked at the impact of hyperglycemia on fibroblast phenotype, specifically in COPD versus non-COPD. COPD stands for chronic obstructive pulmonary disease and is characterized by two major phenotypes, emphysema and bronchitis. Emphysema results in a lot of tissue destruction as well as extracellular matrix protein loss, and also an inability to repair that loss, and therefore you get a hypercompliant, worn-out state of the lung. On the other hand, bronchitis results in a lot of fibrosis, collagen deposition, and mucus hypersecretion, and it narrows and hardens the airway. Our primary goal this summer was to look into the synergy between the COPD and diabetes and to investigate that link. We hypothesized that hyperglycemia would cause cellular senescence and inflammation in COPD airway fibroblasts when compared to non-COPD. We used fibroblasts to study this phenomenon and synergy for a few reasons. They are primarily structural support cells of the lung, and their function is to secrete extracellular matrix proteins. They play important roles in wound healing and fibrosis, and COPD airway fibroblasts in particular are already known to have an altered phenotype when they're more inflammatory, senescent, and fibrotic. We used two main methods to look at this: proliferation assays as well as qPCR. In proliferation assays, we essentially used host dye to visualize the cells and took various cell counts at various time points. We cultured the cells in both low glucose and high glucose to compare their proliferation that way. If you direct your eyes to the right corner of our poster today, you can see that high glucose caused a decrease in the rate of proliferation in COPD fibroblasts and had no change in the non-COPD fibroblasts. Secondly, we used qPCR to look at gene expression levels, and we looked at a few markers, including P21, a senescence marker, IL-8, an inflammation marker, and collagen 1A1, a fibrotic marker. The graphs here for qPCR are divided up by whether or not we differentiated them by disease status, graphs D to F, as well as combined fibroblasts from COPD and non-COPD, A to C. In terms of P21, the senescence marker, we can see that there was no real change when they were cultured with high glucose or TGF-beta. But in terms of IL-8, the inflammation marker, in the combined cell graph, we see that high glucose caused a spike in this inflammatory marker, and this effect was mirrored in the COPD versus non-COPD cells as well, even more so seen in COPD. In terms of collagen, in the low glucose conditions in combined cell graph, we see that there was a spike in collagen as soon as we added the TGF-beta stimulus. This is expected as TGF-beta is a pro-fibrotic mediator. However, this spike was dropped in high glucose, indicating a reduced response to TGF-beta and implications for wound healing and repair. This was again seen in the COPD versus non-COPD graph as well. And interestingly, we can also see that COPD fibroblasts have this effect even in the low glucose condition, indicating that we're on the right track.